Hello everyone, welcome to your chemistry classroom. I am Lawal Alitunji, your chemistry tutor. To our new viewers, welcome to chemistry classroom. Please do well to press the subscribe button, turn on your notification button, press your like and share button, and put your comment in the comment box. To our returning viewers, welcome to your chemistry classroom. As we have all know that we are in the season of NECO, and I believe you have watched all the videos we have released so far from the chemistry practical. This is another video that you are bringing to your screen to watch right now. Please do well to watch the video from beginning to the end, and likewise hold your pen and your book, also working it out, and let's do it together. Here we have the question. We have another quantitative analysis, titration, and the question is on the screen saying you are provided with the following. Solution A contains 150 cm cube of triazonitrate 5 acid HNO3 prepared by diluting 6.30 cm cube of concentrated triazonitrate 5 acid per dm cube of solution. While solution B contains 150 cm cube of a mixture containing 5.5 gram of sodium triazocarbonate 4 Na2CO3 and 2.5 gram of sodium triazonitrate 5 NaNO3 per dm cube of solution. We have our indicator, that is methyl orange, and they say using the apparatus provided, carry out the following experiment and answer the questions that follow. Experiment now say fill the burette with solution A, that is acid. We all know that our burette is always 50 centimeter cube capacity, so we need to fill it with our acid, that's solution A. And using our pipette, your pipette can be 20 centimeter cube, it can be 25, but here I'm using 25 centimeter cube to transfer the base into a conical flask and add 2 to 3 drops of methyl orange indicator to the base. When after doing that, you need to shake very well before you start running your acid on it. So they say titrate the solution A until the end point. Now this end point is talking about, before you add methyl orange, you'll be seeing a colorless. After putting methyl orange, you have yellow. At the end point, after running acid, you have orange, pink, or red. Now this is to turn from yellow to orange, pink, or to red, anyone. So repeat the titration to obtain the concordant titers and they put values, and we all know that our difference is always plus or minus 0.2 in the titer values. So now the questions. The question is, tabulate your readings as shown above and calculate the average volume of the acid used from the concordant titers. In my own titration here, I'm going to use 22.60 centimeter cube as my titer value. So I will prepare a table on that. In your own environment, you carry out the experiment on it so that you have your own titer value. My own titer value would be during my experiment, and after I'm using now 22.60 centimeter cube. Now question B says calculate the number of moles of triazonitrate 5 acid HNO3 in the average volume used, given that the molar concentration of solution A is 0.10 mole per dm cube. And this talks about the equation. We know what equation will be, that sodium carbonate plus HNO3, that's hydrogen triazonitrate 5, to give us sodium triazonitrate 5, H2O, and CO2 as our product. And under that equation, we have 1, calculate the concentration in mole per dm cube of sodium triazocarbonate 4 in solution B. And Roman figure 2 said we should find the number of moles of sodium triazocarbonate 4 in 25 cm cube of solution B. While the question D says we should calculate the mass concentration in gram per dm cube of sodium triazocarbonate 4 in solution B, given the atomic mass sodium 23, carbon 12, and oxygen 16. And lastly, we are told to determine the percentage purity of sodium triazocarbonate. Determine the percentage purity of sodium triazocarbonate 4 in the mixture. These are the questions we want to solve right now in this episode of Titration NECO 2025. Now here we go. Yes, this is my paper that I want to use to solve all the question, that chemistry practical question. Let me start like this. We have read the questions. Now we need to answer the questions. In the question, a lot of informations were given. Before I will go to my table of values, in this question I want to use my theta value as 22.6. In your own school, you will need to carry out the experiment, but because here I'm only working on the calculation aspect and the content of the question, I'm not carrying out the experiment. That's why I'm picking my theta value as 22.60 centimeter cube. Now, what are the given information? I already have. Remember, I have known that I'm using my volume of base or volume of pipettes. I'm using 25 cm cube. I'm using 25 cm cube. And for my indicator, I am using methyl orange. We've known that one. And likewise, now I can go to my table of values. Now let me draw my table. Remember, I've told you I'm using 22.6. So I will say Burette reading. I will have my rough titre. This time around I want to use 2 titre. In the last video, or one of our videos, the last video I used 3, but this time let me use 2. You can use 2, you can use 3, depends on how you have the time. Always put your unit. You can see mine. Always put your units. And I have my second. If you like, you can write it like figure 1, 2, still the same thing. Second titre. And I have it. So here I have my final reading. And here I have my initial reading. Volume of the acid used. To our returning viewers, welcome back. To our new viewers, if this video you are watching is your first video, please do well to press your subscribe button, turn on your notification button, like and share, and put comments in the comment box. Rough titre, I don't need it, so I can put any value there. Let's assume I'm putting just 5.0, and here I'm making this place to be 48.0. Maybe if I subtract, I'll be having 43.0. I don't need it. Now these are the 2 columns that I need, so I need to prepare very well. If my initial value is 0, definitely I'm working on 22.60. In this place I have my 22.60, and let's say I want to continue from where I stopped. Since my final day was 22.6, it can become my new initial. So since I still want to derive that 22.6, if I sum up this, I'll be having 45.20. With this now, my value stand. I have my volume of acid, so I can now go straight to what we call the average titre value. Average titre value, that is, I'm using first titre plus second titre divided by 2. And what is my first titre? That is, I'm having 22.60 plus 22.0, the 2 over 2. Let's work with calculator for accuracy's sake. So I'm having 22.6 plus 22.6. So here I'm having 45.2, that is 45.20 over 2. When I divide, I have 22.60 centimeter cube, and this is the volume of acid used. The volume of acid that can also call VA. So moving forward now, I can now write my equation. The equation is talking about relationship between NO2CO3 plus HNO3 to give us NaNO3 NaNO3 plus CO2 plus water. So I need to balance the equation. If I have 2 here, I have 2 here. I think the equation, I have 2 sodium, 1 carbon, 1 carbon, 3 oxygen here. I have how many oxygen here? I have 6, making 9. 6 again, 3 here, 9. Hydrogen 2, hydrogen 2, nitrogen 1, nitrogen 1, and it is balanced. And this is 1:2. 1:2. 1:2. Now the mole, or you say number of moles of Na2CO3, that one is 1 here. You can say mole, you say number of mole, we are saying the same thing. And here for that of acid, number of mole of HNO3, we have 2. We can still call it, maybe if you say, and here Na is 2. We are still saying the same thing. Alright, now let's now go straight to the next question. They say we should find the number of moles given that the molar concentration, I'm talking about B now. B, I think that should be B1 or ordinary B. It said we are given the molar concentration of HNO3, which you can also say maybe our Ca. We were given the molar concentration of 0.1 mole per dm cube, and we want to find the number of moles. That's what we want to find. And don't forget that we just finished getting the volume of acid. We just finished getting it from our titre value, that is our VA. We got 22.60 centimeter cube. Now you need to recall that molar conc is equals to the mole, or number of mole, over volume, which you can say maybe C equals to N over V. Now this time around, N becomes CV. So our C, our V. So we can now say our NA for this particular with these particular parameters. The NA for this particular parameters is what we're going to find, and our concentrated molar concentration, we have 0.1 times our volume 22.60, which must be converted to dm cube divided by 1000, which means we are saying 0.10 times, maybe we should use calculator to perfect everything because of accuracy's sake, 22.6 divided by 1000. So we are having 0.0226. So when we multiply this, we are going to have 0.00226 moles. That is, this is mole, or you leave it like this anyhow if you want it.